Hello everyone, in this video we will be implementing human pose estimation using Python as a programming language, and for overlaying these lines and points correspondingly we will be using OpenCV. In addition, we will use OpenCV to load already pre-trained deep learning architecture based on TensorFlow. So actually, uh, we have already developed a TensorFlow model to train these human pose estimation, and in this video we are targeting a beginners level, so we will not train the human pose estimation, rather we can just load the frozen models using OpenCV. At the end of this video, we will show you how we can deploy our algorithm on pre-stored videos like this. It's a YouTube video. So in this case, you can see that the algorithm successfully estimate the poses, right? Similarly, at the end of this video, we will also show you that how we can deploy our algorithm using a webcam demo. In this case, you can see that as long as we have the full view of a body, the human pose estimation algorithm can detect all possible 18 points of the body skeleton. Similarly, if we do not have, for example, occluded position, such as some of the points are missing over here, so still human pose estimation manages to detect all possible points in the view. Similarly, in this case, we do not have legs and we have very less points, body parts and points. So in this case, still OpenCV, or with the help of TensorFlow deep learning architecture, still it manages to detect all possible points. Let's get started. My name is Shanullah and I'm a PhD student at Inha University, South Korea. My major is computer vision and deep learning. Let's get started. Okay, let's dive into the implementation of human pose estimation using OpenCV. And the tools we will be requiring in this video is Anaconda. So Anaconda is a great package which contains many IDEs like VS Code, Spider, and others. But the most preferable for this video is Jupyter Notebook. So the beauty of the Jupyter Notebook is that you can make your notes very easily. You will find in the preceding video if you continue to stay tuned. Similarly, the only library we will be using is OpenCV. So in order to download Anaconda, all you need is to just write in the Google search bar Anaconda download, and the first link you will find, just click the individual edition Anaconda and you will be here. And at the downmost side of this link, you will find the executables to download, right? So based on your specifications, like your operating system, either it's 62-bit or 32-bit, you can just download, right? So I assume that it's super simple. All you need is to just download the executable and just press next, 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 and it's super simple to install, right? I assume that you have already installed the Anaconda. So once, if I write in the search bar of the Windows Anaconda, if I click this, you will reach over here. This kind of window will be appear, right? So over here you can observe that some of them are, for example, blue and some of them are green. So the green one are those which I haven't installed. In my case, I have already installed Jupyter Notebook. So in your case, actually all of them will be green, right? So it's better that you just press the install button and Jupyter Notebook will be installed. Now at this moment, I assume that you have already installed the Anaconda Navigator and Jupyter Notebook. It's always better that you must have a window, a folder, for example, sorry, you must have a folder, a separate folder to make a project. So in my case, this is my folder, and I assume that in your case it will be empty. So let's assume that this is empty. And now if I again press Anaconda prompt, okay, so let me zoom in for you guys. So just, sorry, okay, like this. If you write Jupyter Notebook, okay, so I could have opened from using like a launch button over here, but it's better that if you, once you write over here, it will be open Jupyter Notebook. So this kind of window will be appear in your Internet Explorer, right? So once it is here, we are here, just write new Python notebook. So let me separate this. So now I assume that you have just this, right? So you have installed Anaconda and Jupyter Notebook. Now the most important thing is we need to import CV2 as CV, but in your case it will not be installed. So if it is not installed, then write pip install OpenCV dash Python, right? So why is OpenCV dash Python? Because OpenCV is also available for C programming language, right? So it's better that you just write, uh, just execute this command. So in this case, just go to Anaconda prompt. But this time, rather than just clicking it, it's better that you just run as administrator. Okay, so it will be here, and all you need is to just copy and just paste the command over here. Once you enter, everything will be installed, like OpenCV will be installed. In my case, it's already installed. And one another important thing is, for example, you need to install pip install matplotlib, right? So these two important things you need to perform. So in my case, it's already been installed, so I don't need it. So import, second thing I need is import matplotlib dot pyplot as plt. Okay, so these are the two commands I need to perform. Okay, so after I do it, so let me show you some important thing about the human pose estimation. If you go to this link, I will provide this link in my description. So actually this is by Kyung Hoa 92, like this is the author name, and this is the GitHub link I will provide. So actually it is inspired by the OpenCV. um, Actually it's OpenCV example, right? OpenPose is the project name. It's a paper name actually, the very first paper on the human pose estimation, so pretty much stable these days. So this was the example, right? So this guy, what he did is that based on that he provide some easy steps, and already TensorFlow, this is the graph of the TensorFlow already been trained. So using OpenCV we can just load the graph of the this TensorFlow. So all you need is to just press this download the zip. So in my case, actually I have already downloaded this, and extracted it. So once you extract it, the most important thing is this graph, right? So you just need to copy this graph and paste in the folder where you're working, right? So I assume that you have already pasted, like in my case I have pasted like this. Okay, so I assume that you have already copied and pasted this graph. So if I say net, for example, net and cv dot dnn, if I press tab, you can just write it, or dnn, then import, as this the model is from TensorFlow. Okay, so all I need is to write read, and when I press a tab, read from TensorFlow. Okay, and what I need to do is just copy the name of this, right? And what I need to do is this. Okay, so in this case I can just easily upload it my net, right? So in now the TensorFlow model is already been loaded, all the weights, right? So these are our weights actually, right? So these are our weights, and once we do have our weights, so the width, actually as I showed you just the OpenCV actual example, so all the settings are available over here, right? So this is actually during the training of the TensorFlow, all these height and width were set, right? And all these thresholds, and similarly you can see over here the body parts and other things as well. So this is again a very important, like a body parts and pairs. Let we discuss again about it. So if I just press shift and enter, so in order to execute each line, shift enter is the command. Now I can have a list of the, like a body parts and pose pairs. In this case you can see that nose is 0 until 18 we have 18 body parts, and the body pairs are like neck and shoulder, right shoulder, neck and left shoulder. Okay, so for you guys I have again I recommend you that you just visit NanoNet's automate data capture. This is a tutorial by this guy. So it's a very famous and very good tutorial they have written. So actually over here this is a skeleton model of the body, right? So it's starting from nose. It's nose is 0, right, in our case. So you see over here nose is 0, and then neck and right shoulder and then elbow and all 18 body parts we have, and these are the pairs, right? So neck is connected actually. So the neck is connected with what, right? With the shoulder, right shoulder and left shoulder as well. So all of this skeleton, how this skeleton is made. So one another thing, there are many applications for this, like for human action recognition, and many of them there are ample of uh, applications for this, right? So this was the initial design, all these body parts and joints we had. And there was a paper. So if you visit this link, there are so many like deep pose and other papers available. This is CVPR, very famous paper, CVPR, deep pose. Okay, because they were the first to perform everything using the deep learning. So prior to them, everything was performed using the computer vision and other techniques. But after them, they were actually, it was inspired by the AlexNet backend. Again, this is an image classifier, so they use some classifiers in order to point out the points, right, of the body, right? Then CVPR 2015, there were another localization method, right? So actually pose estimation is nothing but a localization of the body parts, right? If I say in the one sentence, it's the localization of the body parts, right? So there was it's a good survey like in CVPR 2016 there. So and still there is a lot of papers going on, like using heat maps, okay, and many other revolutionizing day by day, right? Many other deep learning algorithms are coming up, and very efficient algorithms are coming up, right? So thanks to OpenCV, that we can easily use the TensorFlow model. So it's already been, so in your case you can just run the deep learning. If you're good at deep learning and you can train your deep learning model in TensorFlow, the good thing about OpenCV that you can just load the weights, right? So once let me execute this and shift enter, I press. Okay, so for in my case I have downloaded one of the image from internet. So the name is pose, and for example if I check, it's PNG, right? So in the format is PNG. So let me for example mg is equal to cv dot imread is the command, and for example pose dot, it was PNG, right? So let me load this image, and if I say plt dot show img, so you see over here, but this is BGR actually. So by default the OpenCV format is BGR, blue, green, and red, right? So in order to make it correct, like to show it correctly, it's we need to convert it to RGB. So this is my RGB, okay, image format. And okay, so let me write a function like pose estimation. Okay, so if for example this is image or frame, for example in my case it's frame. Okay, so once I have frame, so it should be dynamic, the code should be dynamic, must be dynamic, right? So frame shape we can read, like width and height we can read, right? Then for example we can have, wait a minute, okay, once I do have it. Okay, so this is net. So I am now configuring my this net, right? What I have loaded in my memory. I'm just doing the configuration. So what are the configuration? Actually, if you just write net like net dot, if you press the S, this is set input, right? So it's automatic. If you have installed the OpenCV, you will see like this, and then cv.dnn.blob from image. Actually we are just grabbing the image, right? So this is the scaling, and this is in width and in height. Okay, this was the setting actually during the training it was performed. And what is it? It's a mean, right? So for example 255 divided by 2 is 127.5, right? So this is 127.5. So we are averaging all of them, and then this is swap RB. So in during the prediction, we don't need to swap it again and again, right? So if we read in the BGR, it will perform, like if we make it true, it will perform automatically. Okay, these were some settings. Okay, so okay, so these were some settings. And for example, rather than waiting, I think I should copy all of the code from my notes, and you can just I will share the GitHub links, and you can just download the code from there. The main purpose of this video is to learn, right? So we are learning these things. So length of the body parts, for example, in our case it is 18, right? And then we need to find the points, right? We need to find the points of this, like nose. What are the body parts? Like nose, neck, or the right shoulder, all of the maximum points we need to find it out, right? So this is the point, this is a list, right? So this is our list. And then in the length of the body parts, like we have 18 body parts, right? We are generating heat map. Okay, and then we need to find the local maximas actually, right? So the description is also available. And then once we find the points, right, and xy points, and then we need to append in the points. So whatever point we find, for example, we find nose, we need to append this point. And we know any point we found, like nose, shoulders, all of the points we need to find out, right? Once we find all of the possible points, for example, in the introductory part I told you that, for example, if the skeleton is not available, so maximum points I can find, for example, nose, my shoulders, and other elbows and other points. Once I find, I need to append all of them one by one, right? Once I append all of them, now I need to pair them all, right? I need to join them. Like for example, the nose is fine, and nose to neck and shoulders and all of these things we need to join. So this is the joining point, right? All of them is the joining. Once we join, we need to draw. like for example, for line we need to draw. For example, this is BGR, you will see shortly that this is green, and this is again BGR, this is red. So the points are red in color, make sure, we will show you soon. And the lines are in green color, right? So if I execute this function, so it's actually executed but not called yet. So let me call this. Okay, so let me call this function. For example, this is my function. So what I need to do is estimated image, right? For example, I need to call this function. In my case, the name is image, right? I hope so. Let me check. Yes, this is img, and let me call this function. Now I have executed. So if I execute this, for example, let me copy this. Okay, so this is estimated image, and once I estimated, okay, now you can see over here, as I told you before, that all of them are either green, like the lines are green, right? So all of the lines are green and the points are red. You can change it. For example, if you do it 0 0 0, it will be black, right? If you do it 255 255 255, it will be white. So BGR, so whatever you do it 1, which is 255, so it will be the color, right? BGR, this is, in this case it's red, and this is it's red, right? So I hope till this point you are already reached over here. So now it's time to perform this demo for video, right? On video. Okay, so for example, if you have already stored some video, you were shooting your video a few months ago or many time ago, and you want to know what is the estimation of my video, so it's better to have it like this. So let me okay, so in my case, for example, I have already, this cv.video capture is the command, both for the webcam and also for the image, as for the video as well. Okay, so once it will start reading the video, and we do have some settings, like for example, it's optional in your case. For example, let me change the size. So this is my index of the setting, and this is my size of the height. For example, I want to resize it. If you don't want to resize, it's okay, it's up to you, it's just optional one, right? In this case it's 4. So height and width is now 800 by 800. You can just change it in your case. Okay, so for example, let me add some for in my case, for example, if the video is not open and it is corrupted in having any reason, and okay, so it should show that it cannot open the video. Okay, okay, so as the pose estimation takes time, so for example, by waiting for 1 second, we will keep going for infinite loop. Okay, so once for example, this cap, we need to read this cap, right? So if it we need to read this video frame by frame, because the video is nothing, usually it is 25 frame per second, or up to 50 or 60. For HD videos it is 60 videos per second. So videos is nothing but a combination of images, right? So I assume that it will read image by image the whole video. And what if the video is corrupt inside, right? So we have to find. So okay, we should go for the next video, either we should break or we should go for the next sorry, frame, right? Once we do have it, I can copy like all of my this function, like from here. Okay, you can just copy, but make sure you have to remove the uh, okay, just copy and just return. You should remove the return, right? Because it's not function anymore. Now I need to copy all of them, and you can see everything is almost same, right? So once I have everything same, and one important thing I can do it over here is that, for example, I let me name cv dot I am show. Okay, let me say that it's a video tutorial. Oh, it's a pose estimation tutorial, by the way. Pose estimation tutorial. Okay, okay. And what I need to print over here is frame. Okay, okay. If I do it like this, let me execute Shift Enter. Over here, you can see over here it's already stored video actually. So let me show you this video. This is this one 93 and down. So let me show you the video 93 and then you see. So this was the video. Okay, this was the video, and now it's actually performing the live estimation, right? So we can easily perform the live estimation, right? So it's now turn rather than applying our deep learning post estimation algorithm on pre-stored video, it's time to apply it on a real-time video demo. So in order to deploy this on a real-time webcam demo, so let me copy all of the code we just perform the demo on the video, already pre-stored video. So this time we don't need any video at all. We want, if you have a webcam, okay, you can just perform real-time webcam demo. So what are the changes we need to do? Okay, so the one most important thing you need to do is just write a 1 over here. I hope that you will not have for example, this is webcam. Okay, so I hope you have a webcam, so either it will be registered as index 0 or 1. So this is the dynamic code. For example, if it couldn't find the webcam, it will throw an error. And one another important thing is that cap dot set is equal to cv dot is the cap. Okay, if you write a tab, okay, like this cap. Okay, so this is cap underscore pro. Again, this is not important, but this is when you press fps. Okay, this is the one. So this is again not really important, but it's better that mostly the webcam, in your case the webcam will have different frame per second. So if it is very fast, then definitely it will be unable to perform, right? So we will have a lot of frame per second. So anyhow, if you, these are the option points, right? So it depends, it varies webcam to webcam, right? So all you need is to just either write, or it's just optional, you can just delete it, right? So these were the changes only. We started from the very basic like pose estimation function, then we deploy the function inside our demo video on pre-stored video. Okay, and then now it's time to perform on real-time webcam. So for webcam, these are the only important changes we just did. Now let me execute all this. Okay, so okay, once I execute, I'm here. So it's better to have a whole skeleton of your body, right? So let me make it the camera in a better place. So you see over here, all of the points there, it's just finding all of the possible points, right, for me. So it's better to have the whole skeleton. I hope in your case, your video will be, for example, you can shoot it at a different level or at a distant apart. So it's better to have it. So, okay, so this was our live video demo, webcam demo. So you can just perform everything very easily, right? So thank you so much for watching the video.